Welcome to my video on setting up a system of equations. In this lesson, we are going to learn how to set up a system, meaning more than one equation, when given a specific word problem. So let's get started. Rent-A-Truck charges a flat fee of $29.95 and 43 cents per mile to rent a vehicle. Borrow My Truck charges a flat fee of $45 and 32 cents per mile. For what number of miles will the rental cost be the same at both companies? The first thing we need to do is identify our variables. And usually the best place to do this is at the end of the word problem. Usually it's the last sentence or the last question. So in this case, the last question is, for what number of miles will the rental cost be the same at both companies? The question is basically asking us for two things. It's asking us for what number of miles, and it's asking us what the rental cost would be. So those are going to be our two variables. And so I'm going to write down miles. That's going to be one variable, and cost will be the other. Now we need to determine which one of these is the independent variable, or the x, and which one of these is the dependent variable, the y. I do this by kind of just thinking about this word problem. It's talking about the number of miles and the cost, and if I look back at the beginning, it says it charges a flat fee and 43 cents per mile. Well, let's think about this. Does the cost of something usually depend on something else, in this case the miles, or do the miles depend on the cost? And I believe it seems to make more sense that the cost of something would depend on how many miles you drive it. So we can tell that the cost is our dependent variable, and miles will be our independent variable. So now let's go back up to the beginning of the problem and see if we can start to write our equations. Okay, the first thing I notice is that it says there is a flat fee of $29.95. Now, anytime you see the words flat fee or down payment, initial cost, the starting up cost, that usually means that the number that follows it is the constant, okay? Or if you're thinking of a slope-intercept form of an equation, it would be the y-intercept or the b value. So let's get this first equation started. I'm going to say, y will equal something x plus $29.95. Oops, there we go. Where y equals the cost, and x will be the miles, the number of miles that they're driving. So what would go in place of my blank that I've put right here? How many cents per mile is it? It's 43 cents per mile. So there you go. We've just written the first equation. Y equals 43 cents times x times the number of miles the vehicle will be driven plus the flat rate of $29.95. Now that we've set up the first one, let's try to set up the second one. Again, it will start out with y equals, and the second company we know charges a flat fee of $45, so that is going to be my y-intercept or my b value, and it's positive, so I'll put a plus in front. And then how many cents per mile? It's 32 cents per mile. And so now we have our second equation. Y equals 32 cents per mile plus $45. We are not going to solve this system of equations in this lesson because in this lesson we're only learning how to set up your systems of equations. We will come back to this problem at a later time and learn how to solve it. Now let's look at one more word problem. Lori bought some large frames for $15 each and some small frames for $8 each at a closeout sale. If she bought 22 frames for $239, find how many of each type she bought. Now to identify my variables for this word problem, I go down towards the end of the word problem and it says find how many of each type that she bought. Because we're trying to find how many of each type, that tells me that one of my variables, we could call it X, needs to represent the large frames because we're talking about the two types of frames that she bought. So we could say X represents the large frame and we can say Y represents the small frame. Now you could also choose other variables. You could choose L for large and S for small. I like to use X and Y. I also notice in this word problem that there are two totals that they give us. They tell us that she bought 22 frames and for a dollar amount of $239. So one of my equations is going to be to find out how many of each type would equal 22. So if I'm going to do that, I know that I could say X, which represents the number of large frames, plus Y, which represents the number of small frames, should equal 22. Now I need to find the dollar amount. How much money did she spend on the $15 frames, the large ones? And how much money did she spend on the small ones? So this equation is going to look something like this. $15 times how many large frames she bought, plus $8 for how many of the small frames she bought, and that total should equal $239. Now in this type of word problem, whenever they ask for something with a dollar amount, you've got to make sure that you don't confuse. Remember, this 15 represents $15. So you would never want to put the 15 in the equation that just wants to know how many were purchased, okay? So that is one thing you can always look for. Never put a dollar amount in something that's just asking for a quantity. These are only two of the many types of word problems that there are involving systems of equations. I hope this small lesson has helped you, and I look forward to working with you again. Bye-bye.